Okay, welcome back to the first dark revision session. Today we're going to talk through an entire Key Stage 2 SATs Arithmetic paper. The one we're going to do first is the 2022 paper. So as you can see from the details on the front of this page, it's for Year 6s. There are 36 questions in the paper and 40 marks. The questions that are long multiplication and long division are worth 2 marks per question. What I'm going to do today is to go through at a fairly good pace through all of the methods for each of the questions, every single one of them. And if needed, I will make separate videos on every single method that we need here. There are some videos already on my channel, and I will continue to kind of build that up. But we need to know how to tackle an entire paper. This is the speed run of the arithmetic paper. So here we go. First things first, we have an arithmetic for question 1. 6,155, add 501, add 649. I can see this 1 is going to go with this 49 to make 650. We could just draw it all out as a column addition. That would be absolutely fine. 6, 1, 5, 5. Make sure lining things up properly. I'm just going to give myself a bit more room. 501, 6, 4, 9. Terrible straight lines as ever. 9 add 1 is 10, add 5 is 15. Exchange the 1. 5 add 4 add 1 is 10. Exchange the 1 into the hundreds. 5 add 6 is 11. 12, 13. Exchange the 1 into the thousands. 6 add 1 is 7. 7, 3, 0, 5. Question 2. Anything times by 0 is 0. 989, lots of nothing, is nothing. Doesn't matter what this other number is. Don't fall into that trap. 10 add something is 302. So 302 is the whole amount. 10 and something else. So we can use the inverse for this. 302, take away 10, giving us 292. Put it into the box. And then just think to yourself, does this work? Add your 8 on, gets you up to 300. Add the other 2, gets you to 302. Question 4. 2,400 divided by 2, short division. Set it out like this, bus stop method. Almost definitely with straighter lines than me. 2, 4, 0, 0. Don't try and do it all in your head. How many 2's fit into 2? 1. How many 2's fit into 4? 2, 0, 0. Answer 1,200. Trying to show you as I go through this, you can do the proper method quickly, and that's the best way to do it, neat and accurate. Something add 70 equals 485, so we need the inverse again. 485 is the whole number. To take away the 70 that we know, and that's going to give us the mystery number. 5 take away nothing is 5. 8 take away 7 is 1. 4 take away nothing, put 0 in there if you would like to, is 415. Put it in there. Quick check, 415 add 70. Yeah, that looks about right. Decimal points, please don't panic just because there's a decimal point in there. What I do is start with the decimal point and then work left and right. So decimal point. To the left of it is a 6. To the right of it is a 4. 8. To the left of this one is an 8. To the right of it is a 6. I'm going to put in a 0 just so I match the numbers up. And I'm going to remember that it is an add. Also, I'm going to put a decimal point in my answer as well. Then it's just a normal column addition. 8 add nothing is 8. 4 add 6 is 10. Exchange it across into the ones column. 6 add 8 is 14. Add one more, 15.08. A really quick check here. 6 add 8 is 14 something. Yeah, that's about right. 15.08 looks about right. Just from a quick check. Just because the answer box is on the left-hand side, it's still equal to the other side. You can just flip it around in your head. And we're going to do a short division. 8. Quite a straight line for me. How many times does 8 fit into 2? It doesn't. Exchange the 2 over to there. Quick toolkit. 8, 16, 24. 1, 2, 3 times. Extra 0. 240 divided by 8 is 30. 840 divided by 5, going on a strong division streak, 5, 840. If you need to free up some working memory, do your 5 down the side. You should be able to keep them in your head, but it takes a second. Okay, how many times does 5 fit into 8? Once, with 3 left over. How many times can I fit 5 into 34? 1, 2, 3, 4, 5, 6. 6 to get me to 30 with 4 over, and then if I was to go 35, 40. How many times does 5 fit into 40? 8 times, the answer being 168. We're flying. 7,306. You'd really use one number per box, but I'm trying to draw it big so you can see all of these. 1, 8, 4, 7. So if you set out your place value, 6 take away 7. Can I do it? No. Can I exchange for my 10s? Still no. Exchange for my 100s? 2. Make that a 10. 6 take away 7. Can I do it? I still can't. Turning that 10 into a 9. This is now 16. 16 take away 7. Can I do it? Yes, I can. It's a 9. And because I was clear here, I can see what I'm doing. 9 take away 4 is 5. 2 take away 8, I can't do. 6. Make that a 12. 12 take away 8 is 4. 6 take away 1 is 5. Writing in the number box. Gold standard, 5459. Multiply by 10. I'm just going to look at this number. A bit of number sense here. 1,000 and something times by 10. 1 times 10. It's going to be 10,000 and something. I'm going to use a place value table. 1, 0, 1, 0. 10,000s, thousands, hundreds, tens, and ones. And because I'm multiplying it by 10, I'm moving it one step to the left. Move everything to the left in order. 1, 0, 1, 0. I'm going to have to put a 0 in my ones column there. 10,100. $560 divided by 7. Quick division. 7. Bus stop. I'm going to need our toolkit for this one. 7, 14, 21, 28, 35, 42, 40, 49, sorry, almost lost it. 49, 56. There we go. So 7, how many times does 7 fit into 5? It doesn't. Exchange the 5 over. 1, 2, 3, 4, 5, 6, 7, 8. And put the 0. 80. 4080. 6 times 10 times 11. Doesn't matter which way around you do this, but it might be slightly easier if we match this 6 and 11 off. 6 times 11 is 66. And then times by 10. We can just add a 0 on there, 660. If you did it another way, it would make it a little bit more tricky. You'd end up with, say you did 6 times 10 being 60. You need to multiply that by 11. 1 times 0 is 0. 1 times 6 is 6. 0 there. 1 times 0 is 0. 1 times 6 is 6. And then you've got 600 add 60. Same route, but just take a little bit longer. 1,080 divided by 9. 9 there. Again, you'll notice how many times we're using our times table knowledge, or it's being relied upon. I'm going to use my toolkit. 9, 18, 27, 36, 45, 54, 63, 72, 81. Okay, how many times does 9 fit into 10? 9 fit into 1? It doesn't. Exchange over, so now it's a 10. How many times does 9 fit into 10? Once, with 1 left over. How many times does 9 fit into 18? Twice. A 0 at the end. 120. Use that toolkit and you don't have to hold anything in your head. 500,000, take away 5,000. Well, if I ignore those and there, that just makes 500 take away 5. Put the thousands back on. And I've got 495,000. We could do it in a column subtraction if you wanted to, but we can get rid of the thousands and then add them back at the end. 495,000. Doesn't matter whether you put the comma or not. Okay, 596 times 7. The missing answer is equal to this. We can just imagine it written the other way around. I'm going to set out our multiplication. 596 times by 7. I'm just going to work it through. 6 times 7 is 42. Exchange the 4 over there. 2. 9 times 7 is 63. Add 4. 67. 5 times 7 is 35. Add 6. 41. 4172. 4172. 2.12 divided by 10. So again, I'm going to use my place value, 2.12. So I've got ones column, tenths, hundredths. And because I'm dividing by 10, I know my number's going to get smaller. It's going to be 10 times smaller. And because I've only got 1 0 at the end, I move it one step to the right. 2 thousandths, 100, 2 there. I'm going to have to put a 0 there because I've got nothing to put in there. So here we go, 0.212. Okay, question number 17, and it's our first one for double-digit division. So you could answer the question at the top, actually on the question itself. I'm going to give myself more space. I'm going to do my toolkit outside. 21 out of 22 is 42. Again, 63, 84, 105, 126, 147. Hopefully that's going to be enough. So, two-digit number is never going to fit into a single-digit number. Exchange to 6. How many times can I fit 21 into 67? 1, 2, 3. With 4 over. I've wasted a bit of my time on the toolkit there, but never mind. I've now got 42. How many times does it fit in? Once, twice. And I'm not saying it would never happen, but I've never seen one with a remainder. Usually with a double-digit division, it rounds itself off nicely. So you're expecting to not have a remainder. Fractions now. Question 18. We've got to make the denominators the same. So we've got ninths and thirds. I'm going to convert this second fraction into ninths. I'm going to put a circle around it to remind myself to change everything. 3 times 3 is 9. So the numerator times 3 is 6. That gives me 4 ninths. Add 6 ninths, which overall gives me 10 ninths. But that's an improper fraction. 1 and 1 ninth. 1 whole one is 9 ninths, and the extra one is 10. So 1 and 1 ninth is our answer. That's up to question 18. We move on to a bit more tricky ones now. Question 19. So I'm going to split this into 607. Long multiplication. 607 times 3. Just going to remind myself what's going on. 607 times by 80. Always putting this at the sides. Remember what I'm doing. 3 times 7, 21. 3 times 0 is 0. Add the 2. 3 times 6, 18. 1,821. Now multiplying by 80. So it's a tens number. So I've got to put 0 in there. 8 times 7, 56. Again, you need to use your times tables. 8 times 0 is 0. Bring up the 5. 6 times 8, 48. As long as you've lined everything up and used your squares, we can now, quite a straight line for me, add this. 1 add 0. 2 add 6 is 8. 8 add 5 is 13. 1 add 8 add 1 is 10. 4 add 1 is 5. 50,381. Make sure you use all this detail, show you're working out, because you're looking for a method mark if you don't get the final answer correct. 13.05 times 1,000. Now I know I'm going to get 13,000 and something because I've got a 13 times 1,000. So that's the number I'm expecting. So I'm going to write it out. 13.05. The number's going to get bigger. So I'm going to write in hundreds and thousands and maybe 10,000 as well. I'm going to move 3 places to the right. 1, 2, 3, because there's 3 zeros. 1, 2, 3. 1. Keep the numbers in the same order. 3, 0, 5, 0 in the ones column. You can see there 13,050. 13,050. Quick number check. As I said at the beginning, 13 and a bit times 1,000 is going to be 13,000 and a bit. So we're happy with that answer. Next one, we have a fraction times by, or adding to a mixed number. So I've got 2/3 over here. This one's going to fit nicely. 2/3, add a third is 1. Then I've got my 2 over here. So it ends up being 1 add 2 equals 3. Just looking at these fractions, I've got 2/3, add a third, 3/3, or 1 add 2. The answer is 3. 7/10 then of 30. Firstly, we need to find one of those. 1/10 of 30, same as 10%, same as dividing by 10. So 1/10 is going to be 3. Multiply that by 7 equals 21. Getting out to the final bit now. 23, 8 take away 5.123. The trick with this one, if I've got a decimal number here, I need to make this one similar. 8.000. I'm not changing the number. That is still 8. 8 on the top is the biggest number. 5.123. Now, just treat this, aside from the decimal point, as a normal column subtraction. 0 take away 3, can I do it? No. So I'm going to take it all the way from over here. 7. 0 take away 3, still can't do it. 0 take away 3, still can't do it. 10 take away 3, can do it. 7. 9 take away 2, 7. 9 take away 1, 8. 7 take away 5, 2. 2.877, 2.877. Make sure you close your 8, do it properly. 1/8 divided by 2. I'm not going to go into the method, I'll do a separate video for this, but what I usually do is just ring this and change from divide to multiply. Splitting it up, you've got 1, now 1/16. Multiply the denominator by your integer there, making it 1/16. I'll show you why that works in a separate video, but that method always works on an arithmetic paper and you can move on pretty swiftly. A half and a third looks simple, but not really, because I can't double a half to make it a third. I can't half a third. It's not really working. So I need to work out what the lowest common multiple of these two are, the lowest common denominator. 2 times 3 is 6. So I know I can change them both to 6. Scribble it out so I don't confuse myself. Circle around all of it so I remember to change it all. 2 times 3 is 6. 1 times 3 is 6. 3 times 2 is 6. 1 times 2 is 2. 3 6 add 2 6 equals 5 6. 26 take away 2.012. So this is checking your place value understanding again. So I'm going to do 26.000. Take away. And look where the decimal point is. 2 to the left of it. 0, 1, 2. If you want to put 0 in there, that's also fine. You're not changing the number. Once you've set this up, it's just a normal column subtraction, apart from a decimal point in the answer. So don't be scared of it. Can't do anything with these zeros. Make that 5. 0 take away 2, can't do it. 0 take away 2, still can't do it. 10 take away 2 is 8. 9 take away 1 is 8. 9 take away 0 is 9. 5 take away 2 is 3. 2 take away 0 is 2. 23.988. 23.988. Finish your number so people can read it. 15% of 3,200. Get my pen back on. Always find 10%, which is the same as dividing by 10. So 10% straight away of that is going to be 320. Then I halve that to get 5%. But I'm always coming back to that 10. That's the key one. 160. You could do a short division if you wanted to. 10 add 5 would get you your 15%. So just add those up in column. 0 add 0 is 0. 2 add 6 is 8. 3 add 1 is 4. 480. Does it make sense? Yeah, it's not a bigger number than what I'm starting with. It's a bit more than 10%. Broad number sense says that's okay. Another percentage question. I'm still going to start with 10%. 10%. Same as dividing by 10 or getting rid of a 0. 10% would be 300. Then I just do 10% of that to get to 1%. Get rid of 0 again makes 30. Another 1% if you wanted to be really bulletproof is 30. 1% add 1% is 2%. 30 add 30 is 60. 29. Terrible double-digit division here. Not good for our toolkit, but we're going to go for it anyway. 73. 146. And then I'm going to add those two up for my third element as well. So I know 73, I know 146. 3 add 6 is 9, 7 add 4, 11, 1 add 1 is 2, 219 is my next one in there. And the pattern, 73, 219, 3 add 9, 12, 7 add 1 is 8, add 1 more is 9, 292 is my next one, 292, I hope there's not too many more. And I'll do one more, 292 is my next one. Add 73 again, just to make sure I've got enough to do the question with. 2 add 3 is 5. 9 add 7, 16. 2 add 1, 365. 3, 6, 5. So there's my 1, 2, 3, 4, 5. Hopefully that's enough. How many times does 73 fit into 3? It doesn't. How many times does 73 fit into 30? It doesn't. How many times does 73 fit into 306? 1, 2, 3, 4, but not 5. So I know if it's in 4 times. My target was 306. What it actually got to was 292. So I could count up here, okay? If I go up to 8, that gets me to 300, plus another 6 is 14. If I really wanted to check, I could. So 14 difference, so that's what I'm exchanging, 146. I'm really hoping that that's in my toolkit over to the side, and it is, 1, 2. So I'm pretty confident we've got that correct because there's no remainders. 80% of 115, there's a long way and a short way, let's do it the short way, obviously. 100% of the number is 115. 10% of the number is 11.5. 20% of the number is going to be 22, 23. So I'm going to take it away. To get to 80%, I'm going to do 100, take away 20%, go from the top down. Just to make sure I get it right, 115, take away 23. 5 take away 3 is 2. Exchange to get 11 there because I can't do 1 take away 2. 9. We go 92. Does that sound about right? 80% is most of a number. 92 is most of 115. Sits right with me. Almost there now. Okay, I've got a 7 and a 9. I can't easily make one same as the other. So what's going to be the lowest common multiple? Well, to get that, I can just multiply those numbers together to 63. I can't think of a better way to do it. 63, 63. Make sure I've got my minus in there. Put a circle around it. 7 times 9 is 63. 2 times 9, 18. Over here and put a ring around it again. 9 times 7 is 63. 1 times 7 is 7. Now I just need to do 18 take away 7. 11 over 63. And we move on. Okay, so we can't do this straight away. I've got 2/3 here and I've got a half. Now we've got 2 steps to this. We need to make these denominators the same, and we're probably going to need to convert this because it doesn't feel like we're going to have enough of a fraction here to subtract. So I'm going to convert this to improper. How many halves are there in one whole one? 2. How many halves are there in 2 whole ones? 4. And the extra one here, I've got 5 halves. Take away 2/3. Still can't do it because I've got halves here, thirds here. I'm going to convert them both to sixths. If I can't remember which number to do it to, multiply the denominators together because 6 is going to be in the 2 times table and the 3 times table if you multiply those together. 5 halves. 2 times 3 is 6. 5 times 3 is 15. 3 times 2 is 6. 2 times 2 is 4. Then we've got 15 sixths. Take away 4 sixths is 11 sixths. Or if I could write that in a better way, I could have 1 whole one and 5 sixths. Either would get you the mark. This is probably the better answer. They're writing in mixed numbers. It's a bit better. Terrible writing over the top, but 1 5/6. We're really close to finishing now. A big long multiplication. Again, don't drop the method. 4078 times by 7. I'm reminding myself what I'm doing, giving myself space. 4078 times by 60. Okay, 7 times 8, 56. 7 times 7, 49. Add 5, 54. 7 times 0 is 0, so just bring up the 5. 7 times 4, 28. Down here I'm multiplying by a tens number, so it's going to end in a 0. 6 times 8, 48. 6 times 7 is 42. Add the 4 is 40. What do we have here? 6 times 7 is 42. Add the 4 is 46. 6 times 0 is 0. Bring the 4 up because I can't put 0 there. 6 times 4 is 24. Two very big numbers there. Just do a column addition. Scribble those out if they're going to get in your way. 6 with nothing is 6. 4 add 8 is 12. 5 add 6 is 11. Add 1 more is 12. 8 add 4 is 12. Add 1 more is 13. Just keep it neat. 2 add 4 is 6. 7. And then nothing add 2 is 2. 273,226. 273,226. A lot of work for 2 marks, that is. 10, take away 2 1/4. Firstly, I'm just going to use the integers. I'm not going to worry too much about the fraction. I'm going to do 10 take away 2. 8. Now I know what I've got left over is 8 take away 1/4. So I'm going to think in my head, okay, if I took 1/4 away, I'm going to have 7 3/4 left. You could split it into quarters, but I think we can use our heads with that one. 7 3/4. Just splitting that integer. Don't want to do anything too long. We've got 2 more questions to go. 6 add 4 divided by 2. If ever you see simple numbers, you've got to be thinking, I'm not being challenged on the arithmetic here. I'm being challenged on the order of things. So BODMAS, brackets, orders, division and multiplication, they're equal. Addition and subtraction are equal. So first up is division. So I've got to do the division first. 6 add 2. So I'm doing the 4 divided by 2, giving me 2. And then the next thing on the list is addition. 6 add 2 is 8. You'll see if we did this the other way around, it wouldn't work. So if we just read it from left to right, 6 add 4 would be 10, divided by 2 is 5. So the order really does matter. And then the final question, 4/5 times by 400. You could say 4/5 of 100. We know that 1/5 is equal to 20%. Times by 4. 4/5 equals 80%. So now I've got to find 80% of this. Maybe I could find 1/5 divided by 5 to find 1/5. Divided by 5, 400. Can't fit 5 into 4. 5 into 40 goes in 8 times. So 80, 1/5. I'm writing down notes so I don't have to hold things in my head. 1/5 equals 80 times by 4. 80 times by 4 if you need to. Do 80 times by 4 over here. 4 times 0 is 0. 4 times 8 is 32. I can just bring it up. 320. 320. Does it look about right? 4/5 is most of a number. 4/5 of 400, 320. There we go. So that is the entirety of a Key Stage 2 SATs Arithmetic paper. Now I know I went relatively quickly, but my plan is, and I've already started building separate videos going into detail in all the different types of questions. I just wanted you to see all the method all in one place, how we go from beginning to end. And hopefully the themes you've noticed are, I'm doing a lot of working out, but it's happening quickly and we're being methodical about it. So I'm not making any errors because all of these little steps that we can get lost in our head with, we're writing out every single multiplication we're doing. Skipping back, we're still circling each of our fractions that we're changing. We're still noting down what we're multiplying them by. We're still making sure we're writing things in mixed numbers. We're still using our toolkit and using a column addition, loads and loads of column addition to make sure that we get these correct, because one slip up in your toolkit and you'll blow the answer and you'll lose 2 marks. So none of it is particularly complicated as long as you get a method and drop into that mode of each question. Every time there's a percentage question, you're going to find 10%. Every time you get a fraction question, you're going to try to make the denominators the same. Every time you get a decimal question, you're going to treat it like normal numbers, but you're going to organize yourself so those decimal points are stacked up, and then treat it like any other calculation. When you're doing a long multiplication, I'm going to write at the side, yes, I'm doing 607 times by 3. I'm going to add that to 607 times by 80. I'm getting myself organized and everything is clear as it can be. So as I say, I will go through more videos about each individual method, but this is all bundled together. This is the last and the most recent arithmetic paper for year 6 from start to finish. Hopefully it's helped you build the method or understand the method. You can always replay sections. If there's a particular bit you want more detail in that you don't think I've done a video on, or you want a different version of, let me know in the comments. Like, subscribe, send it to somebody else who's struggling, and we can tackle these and get the maximum amount of marks that we can that you deserve for all your hard work. No silly mistakes. Ciao.